Hello, Teacher Dennis Monday, back with the physics practicals. And as you all know, the physics practicals that we learn in O level are the same practicals that we do at A level. Yes, because at A level there is an advancement that I talked about even in the first video. So this is our lesson 2, the second video, and my emphasis today is going to be about manipulation of data in the main table of results, basically the main table of results, and also in substitutions. Sometimes you call them calculations. We are going to understand the major marking points, and here the areas that I will explore mostly will include, if you are doing addition and subtraction, what do you have to do? In multiplication and division, what do you have to consider? If you are given trigonometrical ratios, trig ratios like sine, cosine, tangent, tan of angles, so how do you treat them? Logarithms, square roots, cube roots, and all other roots, how do you handle them? Okay, so straight away, let me start by looking at addition and subtraction. So if you, in a calculation, you have, or a substitution, you have two numbers that are being added. Let me give you an example. I have 20.6 and I'm adding 6.31. I've not specified the units, I just wrote those. How do we handle that? Now, understand that in addition, in subtraction, we consider decimal places. Please note that. We consider decimal places. Ask yourself, how many decimal places does the first one have? The first one has, after decimal point, there is only one place. So this is 1 dp, 1 decimal place. What about the second one, the second value? 6.31 has 2 decimal places. Okay, now 1 decimal place and 2 decimal places, you write your answer to the lower number of decimal places. Please understand this. We are saying that in addition and subtraction, we consider decimal places, and write, this is for part A. We write the result, what results, correct to the lower number, of decimal places involved. An example is this one. Here we have 1 dp plus 2 dp's. Your answer will be written to 1 dp. 1 dp. Now, if you add 20.6 plus 6.31, you're going to have a 1, a 9, and you'll have a 6 and a 2. So you have 26.91. But this which you've obtained has to be written to 1 dp. So your answer is going to be 26.9, full stop. If you write 26.91, it will be crossed. You write 26.9, like that. Now, supposing it was subtraction. Supposing it was, this is first case, e.g., first one. The second one, supposing we had 20.6 minus 6.31. Same story. As long as what we're doing is subtracting or adding, it is the same story. Please, we all know that this is 1 dp, this is also 1 dp, so, 2 dp's, so our answer will be written to, you write something here, whatever you get, to 1 dp, because even here we had 1 dp, like that. So you can take time and look for different numbers. As long as they're being added or subtracted, we always consider decimal places, and we favor the lower one. Lastly, Roman 3, about this, I may have 0.521 plus 8.99 minus 2 minus 2 minus 2, something like that. So how do you treat that? This is 2 3 decimal places, this has 2 decimal places, and this is a whole number, 0 dps. So your answer has to be written today correct to the lowest number of decimal places. It means that your answer here has to appear as a whole number. 3, 2, and 0, 0 is the smallest. So what do you write here? Just put this in your calculator, this and that, all the 3, and then whatever you get, you write as a whole number. So this you can still do. Please finish this up. Finish up those areas. Now, in the table of results, when we are adding or subtracting, let me first clean and show you what we do in the table of results. So in the table of results, the sum or difference, that is one obtained after adding or subtracting quantities of any 2 or more quantities should be written correct to the lowest number of decimal places involved. Please note that in the table of results, the sum or the difference of any 2 or more quantities should be written to the correct to the lowest number of decimal places involved. I want to give you an example. Here. If I have here values of x in centimeters, and I have values of y in centimeters, kindly note that in any given column, I will talk about the table of results just shortly, the details and how it has to be drawn. In any given column, you always have to ensure that the number of decimal places is the same. I'll repeat that. In any given column, the number of decimal places has to be the same. So what does that mean? Here we have x in centimeters. Let me take an example. I have 5, have 10, have 15, have 20, and 25. Then here for y, I have 16.4, have 21.5, I have 27.0, 31.0, sorry, and then I have 38.7. How did we get these results? Don't worry about that. I'm just giving you examples of results that were already obtained. Our challenge may be, can you get the values of x plus y in centimeters? Now, very many students write that, which is very wrong. If you write it this way, it's going to be crossed. If you write it that way, I tell you, it's going to be crossed. So what do? It's like you're telling us that the centimeters are units of y only. So make sure that you make the bracket for the sum. This is being very stubborn. Now someone may be wondering, teacher, you see, for you have an advantage that you're using chalk, you can even rub and you can even change. But for us, we use a pen. So what are we going to do? By the way, you're supposed to use a pen only. Use a pen here. A pen. That's why you have to be very careful, but not so slow again. So x plus y, what do? Look at this. X is written to, those are whole numbers. Y to 1 dp. So what should we write here? Our answer, look at this. For when we're dealing with addition and subtraction in the table of results, our interest is not about individual values only. Just to realize that this is a whole number column, a column of whole numbers. This is a column of values that have 1 dp, a 1 dp column. So this column we have whole numbers. This column what do we have? This column we have 1 dp. So what should we write here? In this column. In this column we are going to write whole numbers, because whole numbers and 1 dp numbers, the 1 dp is greater. But, please note this but of recent a conclusion was made, and they said that whole numbers should not affect others in addition and subtraction. So in other words, whole numbers will not affect these ones. For that matter, therefore, we are going to write these values here to exactly 1 dp. Confusion? Some confusion. So add here, you get 21.4. Please don't write it as 21, because when you round off to whole numbers, this is going to be 21. So don't write it as 21. Write it as 21.4. Why? It's because the whole number here is not affecting. 21.4 is what I expect you to write, like that. And then you can continue. This plus that is going to be 31.5. Add here, you have 42.0. You add 51.0. You add whatever you get here. All to 1 dp. Please note that. Subtraction, the same story. But I want to bring a special case where an example is if I put this. Because surely, I think it's starting from 2015, around 2015. That is when 2016, when instead of presenting to students values, measure which they will deal with using a meter rule to whole numbers, to 0 decimal places, they have created a harmony. If you can observe through all the practicals from around 2015, you realize that most of the values, even when they are giving them to repeat the experiments or procedures for values of, then they give them values maybe of x equals to 5.0, 10.0, 15.0. So they state the degree of accuracy, even in the given values in the experiment. So I don't need anyone to cause the confusion. Please let me speak that one more time. I said, if this is to hold, okay, let me start from here. This is 1 dp. 1 dp. 0.0, you see? 1 decimal place, 1 decimal place. All these have 1 decimal place. All of them. Even these ones, they all have 1 decimal place. So, our answer here will be written to 1 decimal place. 1 decimal place and 1 decimal place, your answer will be written to 1 decimal place. But supposing this one was to 2 decimal places. Let me just create here some values. I create some values like that. Supposing you had this. This is 1 decimal place. This is these are 2 decimal places. Values of 1 dp plus values of 2 decimal places. Your answer has to appear to 1 dp strictly. But in case this side here, in case this side here, in case we are having whole numbers, like this, the whole numbers will not affect what is this way. Please note that. They will not. So it means that if we have that kind of case and we want to get x plus y, x whole numbers, y 1 dp, x plus y 1 dp. All right, that's about subtraction and addition. We want to cross over now to another part. What about multiplication and division? Multiplication and division. If you are multiplying two numbers or you are dividing them, what do we do? So for part B, please, we don't consider decimal places. We shift our attention to now significant figures. So in multiplication and division, we consider the significant figures involved. Please note that. And our quotient or product has to be written to the lowest number of significant figures involved. I'll give an example. I won't write all those things. Since this is a video, you can easily replay. An example is, suppose I have 25.7 times 11.68 times 11.68. So what do we do? How many significant figures are here? How many? You can see clearly that here we have 3 significant figures. How many are here? There are 4 significant figures. So press that on the calculator. And the answer which you get, let me try to manipulate even here for me. I see what I end up with. So we have here calic, where is it? Calic. 25.7 times 11.6. What do you get? We are getting 298.12. Now remember, we said here we consider significant figures. How many significant figures are here? There are 3. How many are here? There are 4. How many significant figures will our answer have, our result? 3 and 4, which one is lower? 3, definitely. 3 significant figures. So it means that our answer has to be written to 3 significant figures. So let's identify now 3 significant figures. The first one, the second, and the third. So we stop here. So the right answer is supposed to be 25.7 times 11.68 equals to 298. The next value is a 1, which is less than 5. So we just, you know how to round off, I hope. So you write 298. 298, like that. People usually get challenges. Please, you're not supposed to first show this. Just write it straight, like that, and you'll get your tick. Some students get challenges where with issues of significant figures. Let me maybe just take you briefly. Significant figures. Significant figures simply mean non-zero figures, non-zero digits. But a 0 can be significant depending on its location. An example is, if I have 0.0012, how many significant figures are here? This one is not significant, not significant, not significant. You start counting significant figures when you reach a non-zero value. So this has basically 2 significant figures. Then I may have 0.08005. How many significant figures? This one is not, this one is not. This is a significant figure, and this is also a significant figure, but they are not 2. Now they are what we call trapped zeros. These are trapped zeros. Trapped zeros. So trapped zeros are significant, so they also become significant. So here we have basically 4 significant figures. And then lastly, you may have a case where you have what we call terminal zeros, but the ones that come to the right hand side. You may have like 0.260 meters, an example. You obtain in an experiment, you obtain this value. You realize that this value, this one is not significant, this one is significant, this one is significant, and this is also significant. This 0 after a non-zero value in a practically determined experiment, in an experiment, or in a practically determined result, sorry. Let me repeat. The 0 that comes after a non-zero value, a non-zero digit on the right hand side, but when this value here is either a calculated value or a practically determined value, it means that that 0 is significant. So these are 3 significant figures like that. So there are many cases that we shall be considering, but I want just to make this video a little short, and then the manipulation, the details of manipulations shall be made later. That is for multiplication. The same thing applies to division. So for division, what do? Let's still do the same thing. I have 25.7 over 11.68. What do I get? So still here, these are 3 significant figures. These are 4. 1, 2, 3, 4. I want now our answer to appear to how many decimal places? How many decimal places? No. Oh, no. How many significant figures? We are talking about multiplication and division. Whenever you talk about multiplication and division, just remember significant figures. I used to tell students, because of my friend Samantha Francis, so I would say, every time you think about Monday Dennis, that's me, multiplication and division, remember Samantha Francis, significant figures. Very easy for you to remember. So 25.7 divided by 11.68. 25.7 divided by 11.68. The calculator gives me 2.2003424, and so on. So many other digits. So what do we write? We want to pick 3 significant figures because these were 4 down, so we pick 3. 1, 2, 3. You see? So our answer is supposed to be that. You don't need 2 steps, just write it straight away as that. So is this 0 significant? It is significant. Very true. It's a calculated value. What about if it was the other way around? If it was 11.68, divide by 25.7. So what would you write? Divide by 25.7. So what would you write? Mine gives me, I'm getting 0.45. 4, 7, 4, like that, and so many other digits. 4 significant figures, 3 significant figures, our answer has to appear to 3. So we pick, this one is not significant. So we start from here, 1, 2, 3. The next digit is less than 5. So it means that we are supposed to write that. We are supposed to write that. Please, when you write, don't also put those ticks there. Don't put those ticks there. Those ticks are just for purposes of elaboration. In a special case, they may ask you to get, they are what we call floats. An example is, you may be asked to get, if your value of x is 15.8, let me say for example 15.8, and you're supposed to get 1 over x, which is going to be 1 over 15.8. So what do you write? 1 over 15.8 the calculator gives me 0.0632911139 and so on. What are we going to write? What are we going to write? Remember, now someone will say, teacher, 1 has 1 significant figure. So, and 15.8 has 3 significant figures. So we are going to write to 1 significant figure. Nope, not really. So can we write now this to 3 significant figures? Question is why? Why do we say we should write to 3 significant figures? The reason is because the one which you have here is called a float. So there is a special category of values called floats. A float is simply a value which has an infinite number, of decimal places and significant figures. How does that come? In simple terms, it is so accurate. In other words, they usually call them constants. A float, that is a constant. There are some constant values that may not be float, but these numbers, they give any value which is not varying. It's just given to you, like 1 over x. Like sometimes you may do a mechanics experiment where you do, and you get time for 20 oscillations as maybe you get as 30.0 seconds. And you are required so we have someone gets time as 30.0 seconds, and you are required to get time, the period. So we get period. Remember, this is time for 20 oscillations. So the period is going to be, you get this time divided by the number of oscillations, which is 20, giving you 30.0 divided by 20. Now, this 20 which you're dealing with here is a float. It's a float. That 20 is a constant. So it does not affect the result. In other words, our answer has to be written to 3 significant figures because these are 3. 1, 2, 3 significant figures. This is a float, so it will not affect. Our answer has to appear to 3 significant figures. So can we do those two? Can we do those two? And I close up that short part. The first one was, we were getting 1 over 15.8. What does your calculator give you? And then you're also getting 30.0 divided by 20. Where 20 is the number, here we are getting the period, capital T. Yes, capital T. So we are saying n is 20, the number of oscillations. 1 over 15.8, I got 0.0 0, 6, 3, 2, 9. Is it this one? Let me check again. Okay, that's it. 0.06329113992 and so on. Afloat, 3 significant figures. Our answer has to appear to 3 significant figures. This is not significant, this is not significant. So we start writing without counting significant figures from here. So we have 0 is not significant, 0 is not significant, 6 is significant, 3 is significant, we have so far 2, 2 is significant, so we are supposed to stop here. But don't truncate, so round off. Because this value is greater or equal to 5, add a 1 here. So our value is going now to become, what was a 2 now turns into a 3. Our value now becomes that one. Okay. Then here, 30.0 divided by 20. 30.0 divided by 20. This one. The calculator gives us 1.5. 1.5. Now, you write 1.5, you get a 0. It's wrong. Why, teacher, why? Why do they cross my answer? No, and you're just crossing your answer. You have to follow the principles. 3 significant figures, we have 1, 2, 3 significant figures. You are dividing by the number of oscillations, which is just a constant value. So this does not affect. So you're going to write 1.5, those are 2 significant figures. So you have to add another one, which is a 0. So you have 1, 2, 3 significant figures, like that. So take time and practice about significant figures, as we shall also, as I will give you some cases of practice. And like I told you before, you can for your school purchase our book, Demystifying O-Level Physics Practicals. Just very simple manuals. They have all those things that you may require your students to practice about. Okay, now about manipulation of results in the table of results, manipulation of data in the table of results concerning multiplication and division. I'm going to do it in lesson 3. So permit me to take that to lesson 3. But in lesson 2, let's just finish with the trigonometrical ratios, logarithms, and then the roots. Now, the details of manipulation concerning multiplication and division are going to be in lesson 3. Lesson 3. But for lesson 2 here, part B, in multiplication and division, I want you not to forget the following. Do not forget that when we are multiplying, we consider significant figures. And also when we are dividing, we consider significant figures. And we always favor the lower number of significant figures. We favor the lower number of significant figures. That's what we always do. The lower number of significant figures is what we favor. Now lastly, part C, if you are doing trig ratios, we're going to look at trig ratios. So for trig ratios, in other words, let me just write all of them. Sine, cos, tan, and then we may have logarithms. Can be sine of I, sine of cos of r, tan of alpha, log of x. I'm just putting so that they don't appear to be naked. Square roots of whole numbers, square roots of whole numbers. Strictly, not square roots of other values. Now all these ones, sine, cos, tan, log, square roots, and even other roots of whole numbers, you write them to 3 decimal places. Write them to 3 decimal places. An example is, if I ask you to get sine of 60, of course the calculator is going to give you around something like 0.8660254, something like that. You write to 3 decimal places, so this has to be 0.866, full stop. You stop there. You stop there. If you get sine of 30, for example, sine of 30 degrees, the calculator is going to give you 0.5. So you write 0.5, but you say, Teacher Monday said we write 3 decimal places. You calculator, you are giving me only 1 decimal place. So I have to add on. Yes, like that. 0.500. Then you may want to get tan of 15 degrees. This gives us 0.2679, 0.26794, and so on, 49. Now, we said we write to 3 decimal places, so you count 1, 2, 3 decimal places, not significant figures, but decimal places. Now the next one is a 9, so you add here. You will end up with 0.268. So this turns into an 8, like that. Okay, you may want cos of 40 is 0.766, written to 3 decimal places, just like that. Then logarithms. Logarithms. Let me just write in the same space. If you have log of maybe of 5, let me say log of 5.4. Log of 5.4. Log, this is definitely log base 10. What does the calculator give you? Log of 5.4. The calculator gives me 0.73239. So we write 0.732, like that. Okay, then the last bit is, if you are taking for whole numbers, what is the square root of 4? What is the square root of 4.0? This is a confusing scenario. What's the square root of 4? What's the square root of 4.0? When you're taking square roots of whole numbers, you write your answer to 3 decimal places. So this you have to write as 2.000. Teacher. That's it. Don't argue. That's it. That's what we do. 3 decimal places, because this is a whole number. What about 4.0? 4.0, if you press in the calculator, it will give you 2 still. But 4.0 is not a whole number. So you maintain the number of significant figures. What did I say? If you are getting a square root of a value which is not a whole number, you maintain the value of significant figures. That means that you're going to write 2.0. This one had the 2 significant figures, so you write 2.0. 2.0. Just like that. Oh, something very basic. I hope now I've given you some rough idea of how to multiply, how to divide, how to add, how to subtract, how to treat Trig ratios. We shall have different cases coming up very soon, but for now, permit me to stop this lesson 2 at this point. And in lesson 3, I'm going to focus about where most of the marks are concentrated, in the table of results. So until we meet again, I remain Dennis Monday Maximus, a teacher of physics and mathematics. Bye-bye.
yazukira mu bafuye bivuga buri rurimi rwaturenzi Yesu alivuga tumwesiga Yesu Kristo yazukira mu bafu tumwesiga haleluya Yesu tumwesiga yekabaka Yesu Kristo yazukira mu bafuye kabaga haleluya Yesu Olikatonda weunyisa Olikatonda weunyisa Olikatonda